Well, hello once again. We are really zeroing in on the end of this series. The tuner has been installed, and as you can see, those rubber grommets I bought up there in Dayton, Ohio at the Hamvention, boy, they worked great. They just fit perfect. This thing has a nice shock mount, vibration dampers now, which is what those are all about. And one thing I wanted to show you about a tuner, for those of you who haven't seen it yet, you have a part that moves, of course, and then you have a part that stays there, it does not move. The one that moves is called the rotor. The rotor rotates, remember that. The rotor rotates. The one that does not move, which is this one over here, that stays in place, and see that we'll bring the blades down, you'll see the rotor come up through the center, see it? Let me get over here. See the rotor going up in there? These do not move. They're called stator. The rotor rotates, the stator stays. Cool way to remember. That's called a mnemonic device, by the way. Rotor rotates, stator stays. Now let's talk about this tuner. I mentioned in the last video that we needed to find out whether or not it was isolated from the chassis. I did not know. So we went ahead and we checked the schematic. And right away, as soon as I started talking and I showed you that this plate of the rotor was grounded, and I showed you that this plate of the rotor, get a little clarity here, there we go. This plate of the rotor was grounded, and I showed you that this plate of the rotor was grounded to the chassis. All three of those are grounded to the chassis. That automatically told you that this tuner is not isolated from the chassis. Okay, there were a couple of questions, you know, and but another thing I wanted to point out to you here was that some of those rubber grommets have carbon in them, and they are conductive. They're not all like that. If you buy, you know, the nylon, the neoprene, stuff like that, you won't find any carbon. But some of the old rubber types do have carbon in them, and it is conductive. And I don't know if you can measure the resistance through it. Not with the equipment I have, I don't think. You know, never really gave it a thought. Okay, all right, that takes care of that. Now, let's move on to something new. We still have a couple of things to finish up here. This tuning meter, when I fire up this radio, the tuning meter will not yet be installed. So we're going to have to replace that with something. Now, I brushed this by my mentor, Brendan, now that he's back and clicking on all cylinders. I said, you know, can't I just, like, you know, put a jumper wire across there? And he said, well, no, because you need to measure the resistance of the coil on that meter and replace it with the resistance, because the plate voltage is on these are pretty low. And I'm thinking, geez, it's only about 200-300 ohms, I guess. Well, anyway, I went ahead and I dug that thing out of the shed where I had it stored in plastic bags, where it wouldn't get bothered or touched or messed with until I finished the project. I got it out and I measured it, and I was thinking, what, 200-300, maybe 400 ohms at the most. Man, was I wrong. It was almost 1,800 ohms. That was a big surprise to me. I was surprised. I just had no idea. Anyway, Brendan is right as usual, and you'll know that I've replaced the two tuning meter wires. I took away those old nasty ones and spliced on these red ones. So what we're going to do is replace that meter with this 1,800 ohm resistor that I have right here. Okay, let me zero in there to get a little better focus here. All I did was take a isolated, this is what they call an isolated vertical terminal strip. It had two connections on it. I'm going to put this 1,800 ohm resistor there. Then I'm going to hook a wire to each side. That's all there is to it. One here, and the other wire will go over here. And that'll take the place of our tuning meter. And I'm kind of glad this actually came up, because what you're looking at here is an isolated terminal strip. It means the lug that you would attach it to the chassis with, or in this case the tuner or whatever, is isolated. It is not touching either one of the connectors. Okay, it's isolated from ground. So these are just free out there. So I'll go ahead and connect these up, and we'll get back with you in the next segment. Well, there's our tuning meter, folks. Now I'll go ahead and put a piece of tape over that. So when I tune around on the tuner, after we apply power to the chassis, I don't want to be touching that thing with my finger, you know. There'll be some little, quite a bit of voltage on that thing. It'll give me a little sting there. All right. The next thing we have to do is these black wires. This one here, these ground wires. They pick up their ground underneath on the legs of the aluminum covers. A couple of them do. On the legs of the aluminum covers that go over these coils. So we need to get the aluminum covers back on. So, and then put a nut, you know, make sure that the ground tab on the wires are on those things with the external star washers, and tighten them up. So that's our next job. Let's get the covers on these coils. Well, that's that. They're all grounded underneath to provide all the grounds for the circuits. Of course, before I fire this thing up, I'm going to go around, double check every ground underneath to make sure I got them all covered. So let's go ahead and take off this tape and crap from around these things, these tube shield bases. We'll go ahead and do that. I made sure all of this has been no more paint on there. I need to have a good solid ground. We'll take the tube tape off that I put there, and then we'll kind of clean it up a little bit. We might even be able to put some tubes in here and get some of the shields back on. Well, she's starting to look like a radio now. We got all the tubes in. I do not have the grid cap connected to this one. This wire right here has to have the grid cap connector put on it, so I can hook that up. It was pretty mangy, so I had to cut it off, and we'll go ahead and fix it. We ran a new wire up, and this thing has to be clean, and a lot of rust and crap on that baby. And the on-off switch. The on-off switch is bad. I put WD-40 down there. I put contact cleaner. I mean, I finally got it to turn on and off. The problem was the resistance, you know, would go 4 ohms one time, 50 ohms the next, and if you wiggled the toggle around a little bit, it would go up to 125 ohms. And then sometimes you turn it on, turn it off, it wouldn't work. We're going to put a new one on, but that's not a showstopper. We can find one for that, no problem. So I'll tell you what, why don't we go ahead and wrap this up for tonight, and then we'll probably do one more segment tomorrow, and I'll have this thing uploaded hopefully Thursday night. By the way, old Brendan, my mentor, you know, he said it'll be interesting to see if it fires up, or interesting to see if it doesn't. Oh, ye of little faith. I'll tell you what, if it doesn't turn on, it doesn't fire up on the first try, Daniel, cool blue lights, if it doesn't work for the first time, do we concern ourselves with such things? I'll let you give the answer, Daniel. Do we concern ourselves with such things? Well, we finally got enough space on the old workbench that I could move the radio here. I cleared a lot of stuff out. And we are just about done here. I put some tape over this replacement resistor for the tuning meter. Stuck a power cord on it now, a temporary power cord. We hooked up some antenna wires, or put new ones on actually. And we went ahead and put this grid cap connector on. And these grid cap connectors are not in very good shape. I'll be working on those later, but I think they'll be sufficient for a test run to see if this radio is going to play. Now we have one thing left to do. It's about that speaker. Now we're not going to be using the original speaker. The original speaker was a electromagnetic. It had a field coil on it, which is right here. What we're going to, by the way, the field coil was good. It measured out to 1445 ohms. So we're going to replace that, because we're going to be using a permanent magnet speaker for test purposes. We're going to replace that field coil with a resistor of 1500 ohms. Let me hold this thing still here. We're going to put a 1500 ohm resistor there. Yes, we are. Right like that. And we're going to get rid of this field coil. Okay. And what's wrong with this pencil here? Okay, there we go. And of course the field coil was used for filtering the B plus, you know, to get rid of the extraneous ripple and stuff like that. But you know, the resistor can't do that. Now, the resistor will cut the voltage down, but it won't filter it. So we're going to have to put a capacitor on one end of this thing. It'll be electrolytic. My drawing's really bad here. It'll be an electrolytic capacitor to ground, like so. And then we'll hook up our two wires. These two wires that come in here, one will hook to this end of the resistor, the other will hook to that end. Up here, this will be the two wide, the two pins that are wide, okay, on the speaker plug. Up here, the two pins on the speaker plug that are close will have the field coil to the speaker connected to them. Nothing will change here, okay? It's just going to be this right here, resistor for the field coil, and adding that capacitor, that electrolytic. I'm going to put about I think a 2200 ohm, I mean a 22 microfarad, a 22 microfarad in there, rated at about 450 volts. Let's see what that looks like. Well, here's the speaker we're going to be using, the one that I bought for $2 or $3 at that flea market, the St. Joseph flea market. And the reason I bought it was to test out this particular radio, okay? And we have here a terminal strip that I put in with a 1500 ohm 10 watt resistor. Just from one end to the other, just soldered it up. Nothing soldered to these terminals in the middle, nothing. And then I took a electrolytic capacitor and I hooked the positive end to one end of this resistor and over to another terminal strip that I installed right here. So what's going to happen is I'm going to connect a ground wire from the chassis to there, which is the negative side of that capacitor, and then I'm going to hook the two wires I showed you to the speaker plug here and here. Now I still have to solder these in, I haven't soldered them yet. And then the two close together connectors on the speaker plug will connect here. One will go to each of these wires, which goes up and feeds to the field coil on the speaker. That's it. Two wires here and two wires here, one here and here, and then connected to the speaker plug where they belong. Piece of cake. Well, that's it. The old speaker's all hooked up. I've got the two leads connected to each side of the resistor that go to the speaker plug, and then I have a ground wire on the negative side of the electrolytic, which is, like I said, 22 microfarad, 450 volts, and I just hooked the ground wire right here. I may have to find a better place for it, but that should work. And then I have the two voice coil wires connected via these alligator wires, these gator wires, to the two pins that are closest together on this speaker plug socket right here. So that's it. We are ready to hit the switch. Until next time, this is John.